Good morning. Today we are going to discuss or we are going to study standard and canonical forms of Boolean expressions. Standard and canonical forms of Boolean expressions. Standard and canonical forms of Boolean expression. See, standard form. First of all, we are going to discuss standard forms. Standard form. There are two standard forms. They are sum of products form otherwise called SOP, sum of products, and product of sums. Standard and canonical form of expressions we are discussing. Among the standard forms we are going to discuss. Standard forms are sum of products form and product of sums form. See, as far as sum of product forms is concerned, sum of products. See, here AB is a product. Say BC is another product and CD bar is another product. See, this is the sum of three products AB, BC and CD. This is called sum of products form, SOP form or sum of products form. And here one thing you should remember, here AB bar, such a variable is not allowed because this over bar cannot extend from one variable to another. You can have A bar, B bar, you can have A bar, B bar plus BC plus CD bar. It's okay. But you cannot have AB the whole bar or BC the whole bar, etc. etc. That is called sum of products form. And you cannot have such an expression BC AB bar plus BC plus CD bar the whole bar. It is not allowed. The that is this product AB bar plus CD bar plus DE etc etc. That is sum of products form. Sum of products. Okay, sum of products. Now, how do we implement this? How do we implement this? Here, see, this is a multiplication, this is another multiplication and another multiplication, and after that you have to add or you are doing the OR operation. See, here AB bar, you are going to take the AB bar, and now we are going to have another AND gate which is having C and D bar as the inputs, and another AND gate, this is AND gate, and to that AND gate we are going to have inputs D and E. See, now what is this? This is AB bar, and means this AND gate multiplies these two and the product is AB bar. And what is the output of this? This is CB bar and this is DE. Now this is the expression F. F is equal to AB bar plus CD bar plus DE. Now you have to OR these three. That means here this is a 3 input OR gate and these are given to an OR gate, and the output is F is equal to AB bar plus CD bar plus D. Okay, this is one method, and this is AND OR implementation. This is called AND OR implementation. And OR implementation of sum of products form. Now I am going to have another implementation, which is in which we are using only NAND gates. Only NAND gates are used. Only NAND gates are used for the implementation of sum of products form. See, for that what we are going to do is, as you know, there are two notations for NAND gates. A NAND gate is represented by these are the inputs, and here you are going to have a small circle here. This is the NAND gate, or another expression is this is another representation of NAND. See how this is done. For example, suppose that you are going to give x, y and z here. This is an AND gate, and after that there is a NOT operation. That means NAND means NOT of AND. That means after doing the AND operation, you are doing a NOT operation. That means here after this AND gate, the output will be x, y, z, and this will be x, y, z the whole bar. This is x, y, z the whole bar. X, y, z the whole bar. And here you are going to give x. Here y and here z. Okay. The input to this is converted to x bar. X is converted to x bar here. Y is converted to y bar and z is converted to z bar. And then you are doing the adding operation, and the output will be x bar plus y bar plus z bar. Here the output is x, y, z the whole bar, and here the output is x bar plus y bar plus z bar. The input is same. Here inputs are x, y, and z. Here also inputs are x, y, and z. Okay. Now, as per De Morgan's law, x, y, z bar is equal to x bar plus y bar plus z bar. That means both of these representations can be used for NAND gates. Both the representations are meaningful. Now, using only NAND gates, how do we implement sum of products form? See, now this is a NAND gate, another NAND gate, and another NAND gate. Through these three NAND gates, you are going to, that means A, B bar, C, D bar, D, E. Okay. Then you are taking the output. Here also you are taking the output and output. Then this is NAND gate. See, what is the output of this? A dot B bar the whole bar. Here, A dot B bar the whole bar. The output of this NAND gate will be A dot B bar the whole bar. And what is the output of this? What is the output of this? C dot D bar the whole bar. Or C D bar the whole bar. And here what is the output? D the whole bar. D E bar. Okay. Now, when you are doing the NOT operation, A dot B bar the whole bar becomes A B bar. That means this NOT will go, this bar will go. And what about C D bar the whole bar? When you are taking the NOT operation, then that becomes CD bar and DE bar becomes DE. Then do the addition operation, you get F here. Okay. That means here using only NAND gates can implement sum of products. You can implement sum of products. Now, standard form of this is sum of product form, and now the standard form sum of products standard form of sum of product form. See, suppose that you have AB plus BC plus CD or AB plus BC bar. Suppose that simple example I am going to take AB plus BC bar. Here how many variables are there? A is a variable, B is a variable, C is a variable, and A and A bar. A, that means A bar is a complement of A, B is the complement of B bar, and C bar is the complement of C. Now you have three variables A, B and C. You have three variables A, B and C. Now the standard form, in the standard form, every term of the product should have either A or A bar, B or B bar, or C or C bar. That means in every term there should at least be A or A bar, B or B bar, and C or C bar. Here we don't have C term. Here it is lacking C term, and here it is lacking the A term. Okay. Now, how do we convert this to standard form? The standard form suggests that, or standard form is, it should have every variable in every product. Every variable in every product. That means either A or A bar, B or B bar, or C or C bar. Okay. Now, AB. Now, I am not having C here. For that, I am going to multiply this AB with C plus C bar. C plus C bar. Why? C plus C bar is equal to 1. Multiplying this with 1 doesn't make any change. So I am going to have AB into C plus C bar plus, here I am lacking A. So I am going to multiply that with A plus A bar. A bar into B C bar. See, here multiplying AB with C plus C bar. C plus C bar is actually it's 1. That means AB into 1 is 1. A plus A bar. Here we don't have any A in it. So I am going to multiply that with A plus A bar into B plus C bar. Now that becomes A B C plus A B C bar plus A into B C bar plus A bar B C bar. Okay. Now this AB plus B C bar becomes ABC plus ABC bar plus ABC bar. ABC bar plus A bar BC bar. Here these two terms are same. These two terms are same. Now this is 0 or 0 is equal to 0. 1 or 1 is equal to 1. Likewise A plus A is equal to A. So I am going to replace this with only one ABC bar. Now this becomes ABC plus ABC bar plus A bar BC bar. This is the standard form of AB plus BC bar. Another example also I will show. I will show you another example. Suppose that the term is AB plus BC bar plus CD. Suppose that AB plus BC bar plus CD. Here the terms are A, B, C and D. So every term, every product should have A or A bar, B or B bar, C or C bar and D or D bar. Here we have three products. Here it is lacking what? C and D. So I am going to multiply AB with C or C bar and D or D bar. And I am going to multiply this BC bar with BC bar. It is lacking A. So I am going to multiply that with A plus A bar and D plus D bar. Okay. Plus CD into A plus A bar into B plus B bar. And after that, you have to simplify this. That means this becomes ABC plus ABC bar. Then that has to be multiplied with D and D plus. I'll show you this one. ABC plus ABC bar into D plus D bar. That is this one only I am going to multiply. Then that becomes, this is ABCD plus ABCD bar plus ABC bar D plus ABC bar D bar. ABC bar D bar. Okay. Likewise, you have to multiply all these terms. Here every term, every product should have 4 terms. One belongs to A, B, C and D each. Okay. That is the standard form of sum of products expressions. Standard form of sum of products. Now we are going to have product of sums. Product of sum. Product of sum means you are going to multiply. First of all, you have to take sums and then you have to take products. For example, going to have a sum like say A plus B into C plus D. A plus B into C plus D. We can have A plus B into C plus D, or we can have A bar plus B into C bar plus D. Standard form product of sum. Product of sum, for example, f is equal to x plus y plus z into x bar plus y plus z bar into y plus z. For example, this is a sum, this is another sum and this is another sum. That means you are going to have x plus y plus z into x bar plus y plus z bar into y plus z. That means this is product of, that means here this is a sum, this is another sum, this is another sum, and you are going to take the product. You are going to take the product. That is why you have the name product of sum. And when you are talking about standard form of product of sums, say just like our previous example where sum of products we discussed, here in this you have the terms x and z. Here you have x bar, y and z bar, and here in this case you have y and z. Okay. Now this term is lacking the term y, and this is lacking the term, every term is there. Here we have x, y and z. Now here you have x bar, y, z bar. That means all the three terms are here. Here this is lacking. What is lacking? Here the term y is lacking, and here we have x is lacking. X is lacking. For that, what I'm going to do is, now here in this case, here this is equal to x plus z, the term, and you're going to add y bar to this. As you know, y into y bar is 0. If y is 0, y bar is 1, and if y is 0, y bar is 1. That means anyway this is 1 into 0, which is 0. That means adding this y bar doesn't make any change to the result. So x plus z plus y bar into x bar plus y plus z bar into, see here we are lacking the term x. So you are going to have y plus z plus, you are going to add x bar. Then what will happen? Here we have a result. In the earlier postulates, we have a result a plus bc is equal to a plus b into a plus c. A plus b into a plus c. A plus bc is equal to a plus b into a plus c. Here x plus z into y bar. This you are going to take a, and this is going to take bc. Then what will happen? X plus z plus y bar. Then you have to treat this x plus z as a and y bar as bc. Then what will happen? This is x plus z plus y into x plus z plus y bar. What is a plus b? That means x plus z plus y into x plus z plus y bar, a plus b into a plus c, that is x plus z plus y into x plus z plus y bar, plus you are going to keep this as such, that means into x bar plus y plus z bar into, what is this? Here again you have to take this as a and this as bc. Then what will happen? A plus bc is equal to a plus b into a plus c. Now we have y plus z plus x into y plus z plus x bar. Okay. Now this is x plus y plus z, and this also is x plus y plus z. Then a dot a is equal to a. That is why you have to keep only one of them. So no need to have this. Then what is this? All other terms are different. Then the result is f is equal to x plus y plus z into x plus y bar plus z into x bar plus y plus z bar into x bar plus y plus z. Okay, that is standard form. And standard form of product of sum and sum of products, how do we find it? We discussed. Now we are going to we are moving on to another example, and some examples we are going to do, that is convert to standard form AB, standard form AB plus BCD, B into CD plus EF. How do we do that? This is F is equal to AB plus BCD, B into CD plus EF, standard form. Now first of all you have to convert this to sum of products form, that is AB plus multiplying BCD plus BEF. Now what are the literals in this? A, B, C, D, A, B, C, D, E, F. A, B, C. That means if this has to be in standard form, every term should contain either A or A bar, B or B bar, C or C bar, D or D bar, E or E bar, and F or F bar. Here this is lacking. A, B into C is not there, C into C bar, D plus into D plus D bar into E plus E bar and F plus F bar. That means all this multiplication you have to do. Then what about BCD? It is lacking A, so you have to multiply that with A plus A bar. BCD is there. E and F are lacking, so you have to multiply that with E plus C bar and F plus F bar. Here, what all is lacking? What are lacking? A, C, D, A, C and D. So you have to multiply this with A plus A bar, C plus C bar and D plus D bar. In that way, we can find out the standard form. Now, see another example is A plus B bar, A plus B the whole bar plus C the whole bar. A plus B bar, A plus B the whole bar plus C the whole bar. Now, using De Morgan's theorem, you treat this as X and this as Y. What is X plus Y the whole bar? Is X bar dot Y bar. Now, that becomes A plus B bar, that is X. A plus B bar, A plus B the whole bar is X, the whole bar dot Y bar dot C bar. This A plus B the whole bar, A plus B bar the whole bar means that is A plus B into C bar. That becomes A C bar plus B C bar. This is sum of products form. This is sum of products or SOP form, and you have to convert that to standard form. How do we do that? Here the terms are A, B and C. Here this is lacking the B term and here we don't have any A term. That means you are going to multiply AC bar with B plus B bar, and here this is lacking BC bar into A plus A bar. It's not having any A term. That means this becomes A B C bar plus A B bar C bar plus A B C bar plus A bar B C bar. A B C bar. Here this is A B C bar and here also A B C bar. So you have to keep only one. That means A B C bar plus A B bar C bar plus A bar B C bar. So this is the result. That is converting this to standard form. First of all, you have to convert this to sum of products form, and in this sum of products form, what are the terms lacking in it, or what are the terms that are not present in it? Here B term is not there, here A term is not there. So for that you are going to multiply that with B term, and here as it is lacking in A term, we are going to multiply that with A plus A bar. A plus A bar is 1, there is no change in the value. Here also multiplying B plus B bar. B plus B bar is 1, so there is no change in the end result. So after that we are going to multiply, and here ABC bar plus ABC bar, that means 1 or 1 is 1 and 0 or 0 is 0. That means ABC bar plus ABC bar is ABC bar itself. That is why this result. Okay. Now we have product of sum form. Now I am going to show you some conversion from product of sums to its standard form. For example, a bar plus b into a plus b bar plus c. This is in product of sums form. This is in product of sums form, but it is not standard form. Why? Here it is lacking the C term. It is not having any C term here. So for that, this is f is equal to, this is the function a bar plus b into a plus b bar plus c. Now you are as it is not having any C term here, you are going to add c plus c bar here, c bar here. That means a bar plus b plus c bar into a plus b bar plus c. Now this is a bar plus b plus c bar. That means we have a result a plus bc is equal to a plus b into a plus c. Here we have such a result a plus bc is equal to a plus b into a plus c. Likewise here you have to treat this as the first term and this is A and this is BC. Okay, that means, or consider this as we have a result x plus yz equal to x plus y into x plus z. Likewise, here you are going to treat this as x and this is y and z. Now, a bar plus b plus c into a bar plus b plus c bar into a plus b bar plus c. Okay, this is the result. That means this is in standard form. Standard form. Now we are going to discuss what are canonical forms. Standard forms, the discussion of standard forms is over, and now we are going to discuss canonical forms of Boolean expressions. Canonical form. Canonical forms. If you have a single variable x, suppose that you have a single variable x. The canonical forms are x and x bar. Canonical forms are x and x bar. If you have a single variable, then x and x bar means if x and x bar, if x is 0, x bar is 1, and if x is 1, x bar is 0. This is the truth table for that. That means this is x and x bar. Now, if you have two terms or two variables x and y, if you have two variables x and y, then see here you have two terms x, y. Suppose that x is 0 and y is 1, y is 0. X is 0, y is 1, x is 1, y is 0, and x is 1, y is also 1. So, these are the terms. Okay. Then, what is this? xy. This is x is 0, y is 0 means this is x bar, y bar. X is 0, y is 1, we are going to treat it as, that means if x is 0, then x is x bar, while this is considered as x bar. That means if x is 1, we treat it as 1. If y is 0, we treat it as y bar, and if y is 1, we treat it as y. That means this is x bar and y bar, this is x bar, y bar, this is x bar, y, this is x, y bar, and this is xy. That means Here, how many min terms are there? How many min terms are there? X bar y, x bar y bar, x bar y, x y bar, and xy. Okay, xy. Now, suppose that you have three variables, three variables x, y, z. Say, suppose that you have three variables x, y, z. This the value of this is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Actually, I am writing 0 1 2 3 etc. up to 7 in binary. This is 0 1 2 3 4 etc. up to 7 I am writing. And what is this? X bar, y bar, z bar. What is this? X bar, y bar, z. What is this? X, y bar. This is not x. X bar, y, z bar. This is x bar, y, z. What is this? X, y bar, z bar. This is continuing with canonical forms. Continuing with canonical forms. Here, these are x, y, and z. This is the min term. This is the designation of the min term. This is max term, and this is the designation of the max term. Designation of the max term. 0 0 0. This is x, y, and z. The x, y, and z are three variables, and now we are going to discuss what are min terms and what are max terms, and what are the designations of those min terms and max terms. Here x, y, and z, the value of x is 0, y is 0, and z is equal to 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. That means these are the 8 different possibilities for x, y, and z. And how to code this is, that means this is the binary for 0, that means 3 bits of the binary for 0, 1, 2, 3, etc. up to 7 you have to write, then you will get different combinations of x, y, and z, the values of x, y, and z. Then how to write the min term? That means this x is, when x is equal to 1 we call it as x, and when it is equal to 0 there is x bar. That means here this is 0 and this is 0, this is 0, that is why we have x bar, y bar, and z bar. X bar, y bar, and z bar. 0 0 means 0 stands for x bar, 0 stands for y bar, and this one stands for z. That means x bar, y bar, z. 0 1 0, that means this is x bar, y, z bar. And likewise we have filled it up. That means the last one is 1 1 1, x, y, z. That means x, y, z. So these are the min terms, and those are represented by m0, m1, m2, m3, m4, m5, m6. That means here small letter m0, small letter m1, that means these are the min terms. And now these are the max terms. Max terms in the sense, see, how to write this? I will explain this. This max term is the complement of this min term. That means x bar, y bar, z bar, the whole bar. That means I am going to take the complement of this x bar, y bar, z bar. As per our De Morgan's theorem, here I am going to treat this as A and this is B. That means A dot B, the whole bar is equal to A bar plus B bar. Here A is x bar, y bar. A bar means the whole bar plus z bar whole bar. What is z bar whole bar? That is z, that means plus z. And what is x bar, y bar, the whole bar? Again, A dot B the whole bar. A dot B the whole bar is A bar plus B bar. That means x bar bar plus y bar bar plus z, which is x plus y plus z. That means this max term is the complement of this min term. Complement of this min term. So here for all these min terms, you have to find out the complement of that. It is very easy to write that. It is very easy to write that. How to write that? I will show you. Here x bar, y bar and z bar. Now how to write this? Take the complement of this, complement of this, complement of this. You have to write x, y, z. That means complement of x, complement of y, complement of z. That means in between you have to put this plus. Now, what about the complement of x? X bar is x, y bar is y, and complement of z is z bar. In between plus plus. Okay. X bar, y, z bar. Complement of x bar is x, complement of y is y bar, and complement of z bar is z, and in between plus and plus. X bar, y square. What is x bar? X bar complement is x, complement of y is y bar, and complement of z is z bar, and in between plus and plus. What about complement of x? It is x bar, complement of y is y bar is y, and complement of z bar is z, in between plus plus. X, y bar, z, complement of x is x bar, complement of y bar is y, and complement of z is z bar, in between plus plus. X, y, z bar, complement of x is x bar, complement of y is y bar, complement of z bar is z, in between plus plus. And x, y, z, x bar, y bar, z bar plus plus. Okay, that is here m0, m1, m2, m3, m4, m5, m6 and m7. These are the designation for this max term. X max term x plus y plus z is represented as capital M0. Max term, this one is represented as m1. Actually m0 complement is m0 and m1 complement is m1, m2 complement is m2, and like that. Okay. Now, how to design sum of products forms and product of sums forms? How do you design that, or how to do that? Suppose that you have a truth table like this. Suppose that you have a truth table like this. That means suppose that for x, y and z, suppose that these are taking the value 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. That means I am writing this as 0, 1, 2, 3 in binary form, 3-bit binary form. 0, 1, 1, 1, 0, 0, 1, 0, 1, and 1, 1, 0, and 1, 1, 1. So these are the 8 different possibilities for x, y, and z, and the function f is equal to function is f of x, y, z. It is a function of x, y, and z. And suppose that 0, 0, 0 returns 0 and the input to x and z are 0, 0 and 1. Suppose that this 1, this is 0, 0, 0. Suppose that this 1, 0 and 1. These are the functions. That means you have to generate a function like this. That means when the value of x is 0, y equal to 0 and z equal to 0, the output of that function will be 0. And if it is 0, 0 and 1, it is 1. 0, 1, 0, it is 0. And likewise, for 1, 0 and 1, it returns 1. And for 1, 1, 1 also, it returns 1, 4. That means for 3 possibilities, 3 different combinations of x and y, x, y and z, it returns 1. For the remaining 5 returns 0. It will return 0. Okay. That is, here these are the different combinations. Now I am going to design the sum of products form. Sum of products. Sum of products form. See, here for sum of products form, here see this function. In this function you have one here and one here. Now your function can be written as the sum of what does this represent? This represents, that means this is 0, 1, 2, 3, 4, 5, 6, 7. This one represents 1. That means sum of 1. What is this? Sum of 5. And what is this? Sum of 7. 1, 5, 7. Then what are the min terms for this? That means m1 plus m5 plus m7. Or m1 is what? M1 is x bar, y bar, z. X bar, y bar, z plus what is m5? M5 is x, y bar, z. X, y bar, z plus what is m7? M7 is x, y, z. This is x, y, z. X, y, z. X bar, y bar, z plus x, y bar, z plus x, y, z. X, y, z. Okay, that is the sum of products form. And if you want the product of sums form, product of sums. Product of sums. In that case, that function is, you have to select all those zeros. Here, that means 5 zeros are there. 5 zeros are there. And the max term corresponding to that has to be selected. That means max terms are m0. That means the product of, here, this is the product of m0. Then what is m0, m2, m3, m4. This is m0, m2, m3, m4 and m6. What is that? What is m0? m0 is x plus y plus z. That is x plus y plus z into. What is m2? m2 is x plus y bar plus z. X plus y bar plus z into. What is m3? m3 is x plus y bar plus z bar. X plus y bar plus z bar into. What is m4? m4 is x bar plus y plus z. Is x bar plus y plus z into. Last one is m6. m6 is x bar plus y bar plus z. X bar plus y bar plus z. That means here this is the function of, this is a function which is the product of this. Product of sums. This is sum of products. Both are same. X bar plus y bar plus z plus x y bar z plus x y z is equal to this one. That means for generating sum of products form, for generating sum of products, you have to select those rows where there are ones and the min terms corresponding to that has to be selected, and then you have to take the sum. But if you want to find out the product of sums form, in that case you are going to select the zeros, and the max times corresponding to that zeros are selected, and then I am going to do multiplication. Okay, this is the way canonical forms are generated. And with that, today I am concluding the session, and you have to go through all these things in detail, and unless you have a better understanding of all these things, all these concepts, so following the next class is very difficult. So you have to follow all these very well. Okay, thank you.